Hey, well, welcome to this lecture for the Norwalk Community College students. It's going to be lecture 14. It's part A. I believe we're going to have a part B of lecture 14. It'll help you do homework 14, whatever parts there are. Some of this is actually covered in an older homework from 13, and I mentioned that in the homework notes when you get started. But there are these topics I plan to go through right here. I plan to go through, does this point work? Which is commonly known as, is this a solution to the equation? Or is this point on the line? They mean the same thing. When you draw the line, you have a pathway made up of all the points that work in an equation, and this means that that point lies on that pathway. Another thing we're going to do, is this a linear equation? I'll establish what makes an equation, which we should already know from prior work, and what makes it a linear equation, which means what makes it so it will graph like a line. Third topic, find the missing coordinate. Not my favorite part of it, but something we should get a little look at. The Homework and Connect Math for my group asks you sometimes to find the y coordinate, which is second, when they give you the x coordinate. That's fine. That's pretty straightforward when I help you isolate y, which we've been working on in earlier lessons. But there's another part where they give you the y and they ask you to solve for x. Still useful, but not as much. In other words, if you have some trouble with that and you're awesome at solving for the y when you know the value of x, probably going to be okay. This part down here, graphing lines using the 3-point method, pretty straightforward using a bunch of things we've already learned. Put all the pieces together, show you how to substitute in some parts of what we're working on in the past and make points that we put on the graph, and then we sure hope that they line up. If the 3 points form a line, we either made a bunch of mistakes that just got really bad luck, almost never happens, or we got the right solution. If they don't line up, they make a triangle. When they make a triangle instead of a line, one of the points, at least one anyway, is wrong. And instead of having to go back and find our error, which most of my students really hate to have to do, we're just going to go ahead and find a fourth point. And then if 3 of the points line up, those are probably correct. The one that's off to the side is the one that's wrong. No harm done, because the line is just a pathway, and the pathway will be correct. So that's what we're going to get through here in 14a. I'm going to begin with, does this point work? So here's my definition of it. It's called a solution. Remember, we have a solution when the right value of x makes both sides of the equation equal. Now we have x and y both going in, doing the job of making sure that they both hit the same target and create the same value. We don't need to know what the target is. We do need to know that they hit the same target when they're all the way in there. So, solutions. Notice how much that looks like the word solve. Sorry, guys. Okay. To linear equations. You guys just aren't going to work. See, that's...
And it's a drop.
Beatles. All right. Well, they tried to help out, but Ringo was really, not doing much good anyway. All right. Back to work. Oh, man, I'm just afraid I'm going to crush one of the Beatles. And haven't they had a tough enough time already? All right. So, linear equations are points I still got points in there somewhere. Still like paints, I'll leave it. Which are x and y. Now, x and y, if they don't have any little numbers down here called an index, then they mean the letter x and y. But if they have a number here, whether it's 1s or 2s or whatever, they're the same number as each other, it means you got a real number sitting there. And so we're going to not look for letters x and y to work. They don't do anything. We're going to look for numbers to be there and do the job. What do? That do what I call work. Now, I'm not talking about just doing some kind of work. I'm talking about work out. If it works out, it means that both sides of the equation hit the exact same expression when you fully reduce them with the x and y that you have. That's a yes. It does work out. It's a point on the graph, and it is a solution. If they hit two different numbers, I don't care how close they are or why they don't hit, then it's not a solution. Let's take a look at a set of these. I'm going to say this. I'm going to say given the equation, and we're going to use the same equation all the way through these 4 examples. 3x plus 7y is equal to 19. Does each point represent a solution. I'm going to give you 4 points that we're going to try. I've spread them out, mixed them up, and all that, so they do a good job of helping you out with this. Point A is going to be the 0.51. Point B is going to be the 0.41. Now that's an ordered pair, which means the x is first and the y is second, comma in the middle, parentheses on both ends. C, 1,4. And D, 11, -2. Weird thing about solving for points that are on a line or not, and that's this. When we find the solution to an equation that just has x in it, we find the only x in the world called a solution that's ever going to work, and nothing else will have both sides hit the same target. When we do this with x and y, which is two variables, that's coming up here, it's a linear equation, then we're able to put in both points and see that it works. But there's not just one point that works. Any point on that pathway is going to work, so there's way more than one point that's going to work. So it's possible that more than one of these is going to get the answer yes. Here's how it goes. Each time, for A, what we got is 3x plus 7y equals 19. So I go 3 parentheses plus 7 parentheses is supposed to equal 19. What's going in? Well, it can get trickier as far as where things go, where there are fractions, where there are negatives, but the basic concept here is fill those parentheses. Where the x is, you want parentheses around your value for x. Here's a 5. And 7 followed by parentheses around the y, and here y is going to be 1. So now we'll run that out. 3 times 5 is 15 plus, separates terms, 7 times 1 is 7, and then 15 plus 7 actually gets us 22, and the question is, are those the same? Answer is no. That means no, they aren't the same. No, it's not a solution. No, the point is not on the graph of the line. We'll go to B. Same equation, 3x plus 7y equals 19. So when we go for B, we're going to have 3 times the number, so that's parentheses, plus 7 times the number, which is in parentheses, is supposed to equal 19. So that is the same equation that we just used, but now trying 4 for x and 1 for y. In here goes a 4 for x in the x position, in parentheses, so it doesn't look like 34. 7 times 1 doesn't want to look like 71. And we'll come back and see what they make. 3 times 4 will be 12. Remember to use your calculator in any situation where you need it. I'm not here to nail you again for having trouble with times tables or arithmetic. I'm here to find out if you can do the algebra. It's great if you can get 12 plus 7 yourself. 12 plus 7 and then get that to 19 and see if those hit the same thing. And they do. So I put a little check there and I say yes. Now let's say you think I'm going a little too fast. You're in a great position doing this on a computer compared with being in our classroom. In the classroom, you got to raise your hand, admit that you don't know it, or you're lost, or you can't find it. That could be very embarrassing. We have no problem like this in this situation. First of all, there's a video that'll show you a couple things. How to stop the video, how to increase the video so you can zoom in on parts of it, and how to play it at half speed. Also how to load it back up so you can watch that part over again a couple times, slow it down, whatever helps you see it. So you don't have to let anyone else in the class know that you're having any trouble or needing to go over it again. You just do that on your own. So that'll be a big help. Now, what happened is that became a yes because both sides made 19, whereas this one did not. So that's a yes. And the question is, does the point work? Yes, that's the way I got it because it hit the same answer, which means, is this a solution to the equation? Also yes. And is the point on the graph of the line? All those are yes because it worked. So that's what it's about. Did it work? So you can have fractions, you can have negatives. That'll challenge your calculator or it'll challenge your ability to do arithmetic. It may take you longer, may feel like it's harder, but the concept is the same, and it doesn't even always have to hit a solid target like the 19, and you'll get a crack at some of those in the homework problems. So let's take a look at this one. It's the same. 3x plus 7y equals, oh, sorry, I don't need that. I already did 3x. I don't have to change anything, though. I'll just erase it because I need the space here. I need to be able to put an exact value of x in there. 3 times the number plus 7 times the number. Does that one equal 19? Question mark. If you want, you can stop the film right now and go ahead and take a shot at it and then run it through and see if you get the right answer. Another thing you can't do in class. I'm going to keep going, so if you don't stop it, you can watch me do it. But if you think you're ready to try it, go ahead and see how you do. X is going to be 1. That's where X goes, 3 times 1. Y is going to be 4. That's where Y goes, 7 times 4. Order of operations is going to have me make sure that I do 3 times 1 and get 3. I don't add the 7 next, right? I have to do plus. Got 7 times 4 for 28. Those add together, 31. Are they the same? Nope. So did they hit the same target? No. Is there a solution to the equation, this point? No. Is that point, 1, 4, going to be on the graph? No. Let's look what I got here. 4, 1. That's an X is 4 and Y is 1. Turns out that one worked. We did our workout and it made 19. This was 1, 4. 1 before 4. That's a 1 and a 4, or a 4 and a 1 if you want to call it that way, but in order it's a 1 and a 4. Put that and it made 31, does not equal 19. We just backed into why it's called an ordered pair. You can't just say, if I want you to use a 4 and a 1, is that going to work? I have to tell you which one is first, which is second, which is X, which is Y, and that lets you put it in the right way to see if you've got the solution. That's why we call it an ordered pair instead of just a pair of points. It's coordinates, right? We don't just want to call it a point and another point's coordinates or something like that. It's an ordered pair. So order counts and there are 2 of them. All right, now I don't have to slow down the video to have you do this, but you know what I'm going to do, so you can slow it down at any time and stop it and try it yourself and see whether you get a yes or no for this. But I'm just going to go, whenever you're ready to, you can play it through, watch what I get when I do this one. So, you know, in class, those of you that were there, I would say, you guys try it, and I'm going to silently work up on the board, and you try and get the answer, and don't look up till you're done. Now you just stop the tape, do your work. When you're done, play it through, see how you did. Now I will talk it through because you got the tape rolling. So here we go. We got 3 times a number plus 7 times a number, and does that equal 19? Well, what we have is when it's time for X, we need an 11. It's not 311, it's 3 times 11 when we get there. Negative 2, it's not 7 minus 2, you can't call that minus 2, it's 7 times negative 2. Both of those multiplications have to get done. 3 times 11 is 33, plus negative 14 times 14. Doy, I messed up what I said, but you know it's 7 times negative 2. We got a single negative, so will our answer for what that product makes. It's not 7 minus 2 to make it into a 5. The parentheses make sure I multiply 7 times 2 and get 14. Now these are added numbers where one's positive, one's negative. They work against each other. So if I go all the way out and I put the large 33 on top of the 14, always the larger number on top, I recognize they work against each other. One's going in the positive direction, one's going in the negative direction. That means I got to see how much they are different from each other. Got to find the difference between those two numbers. So 3 minus 4 is not going to happen, right? So I'm going to cut this 30 down to 20 and push 10 onto the 3. It now became 20, right there in the tens place is 20, and 13 is kind of jammed in there on the ones place. Now if you know 13 minus 4 is 9, you're all set, put the 9 down there. Been working with you for a long time saying complete the 10 if you're bad at subtraction. What do you got to add to the 4 so that you get up to 10? That's a 6. Add that same 6 right there to the 3, and you're going to get a case where you do 19 minus 0, or sorry, 9 minus 0, fine. And that's going to get to the 9. If you knew it was 13 minus 4 for 9, just go with what you got. But if you have trouble with subtraction, can you make that a 10? With 6 more, make this 6 more. 9 minus 0 gets you the 9. Now there I got 20 minus 10. This is 2 10s minus 1 10, gives me one of the 10s. So now I'm thinking, that's some size 19 for my answer. Not completely done yet. I have to look. That was a positive 33. Negative 14, stronger, it's the positive 33. So that means that my answer will be like the stronger sign, and I'll get 19. Now we go back into the position of what we're trying to do. Are they both the same? Yes, they are, which means yes. Guess what? Does it work? Yes. Is it a solution to the 2-variable equation that we have here, the linear equation? Answer is also yes. Is that point on the graph of the line 3x plus 7y equals 19? Also yes. All of them are yeses. Couple things to look at still, keep in mind, it's possible to have yes happen more than once on the same line. It could happen a bunch of times. The other thing is 4-1 doesn't play out the same as 1-4. That's what ordered pairs are about. So we've reviewed a little bit of stuff and hit on that. This should give you a really good start to get in there. I think it's the first few questions actually on homework 13 that'll let you work on this. So we're going to stop here and we'll let you get back to other parts of lecture 14, but we've done this part. Does the point work? Okay.